Welcome back, guys. Continuing on with Marshmallow Chemistry, today our focus is going to be on alcohols and carboxylic acids. Just like last time, we're going to use marshmallows to build our compounds. The large pink marshmallow will be carbon, the large white one will be oxygen, and the small pink marshmallow will be hydrogens. The UPAC name for alcohols is alkanol, with the formula ROH. The R represents a carbon chain attached to the OH group. As you can see in the molecule, we have a single carbon attached to the OH group. The carbon is attached to 3 other hydrogens, and it then is attached to the OH, making our alcohol. This means that the CH3 part of the molecule would be considered our R. So CH3 is the overall formula for that molecule. When we go to name this molecule, it's like the hydrocarbons we've been focusing on. We need to count up the number of carbons. This molecule has 1 carbon, and the prefix for 1 carbon is meth. Given there are no double bonds, we use an coming from the word alkane, and the OL part stands for the alcohol. So the overall name would be methanol. And this series of alcohols is just like our hydrocarbons. Our simplest is going to be methanol, 1 carbon attached to an OH group, with the formula, as we've seen, CH3OH. The next in the series would be ethanol, as the eth prefix represents 2 carbons. And you can see here that we would have our simplistic version of our formula, C2H5OH. Propanol is slightly more complex, as there are 2 places the OH group could be attached to the carbon chain. This first molecule is showing the OH group is attached to the first carbon, and the second molecule is showing the OH is attached to the second carbon. When we name these molecules, we will need to look at where our OH groups are attached. So it's a good idea to number our carbons, and we can see exactly that the OH is on the first carbon, meaning this would be 1-propanol. You may notice that I have spelt it wrong. There should be an N, spelling it Propanol. The second molecule shows an OH group coming from the second carbon, and this would be 2-propanol. Our alcohols can be broken into 3 main groups. Our first type of alcohols are called primary alcohols. These are alcohols where the OH is attached to a carbon on the end of the chain, as you can see in the first image here. Secondary alcohols is when the OH is in the middle of a chain, so the carbon that the OH group is attached to is also attached to 2 other carbon atoms. The tertiary alcohol group is when we have the OH attached to a carbon, and that carbon is attached to 3 other carbons. So to go over it again, we have primary alcohols. The OH is attached to a carbon bound to 1 other carbon. Secondary alcohols, where we have carbon attached to 2 other carbons, and tertiary alcohols that are bound to 3 other carbons. The next organic compound we're going to look at are called carboxylic acids. The UPAC name for these are alkanoic acids. The overall formula for these is a R, which is a carbon chain attached to a carbon which is bound to an oxygen with a double bond, and then to a hydroxyl group or an OH group. This is often written in shorthand as RCOOH, which I'll often refer to in class as an R2 group. This is not a formal name, this is a silly name I use to help remember it. You can see here the formula, the molecule, is a carbon with a hydrogen, Unlike the alcohols, the R group in these particular compounds can be a hydrogen, or they can be a longer chain of carbon. Given this is the simplest, this is one carbon with a O and an OH. This would be called methanoic acid. The formula for it would be CHOOH. And if we draw the structure of the compound, you can see that we have the carbon double bound to oxygen, then to an OH. The next in the series would be ethanoic acid. This is the key ingredient in vinegar. Acetic acid is the common name for ethanoic acid. As you can see with methanoic acid, we have our carbon chain. At this time is a CH3 attached to a C, and from that carbon we have a double bonded oxygen and a hydroxyl group, an OH. The next we will see is propanoic acid, following the same trends as the hydrocarbons. I won't go through its structure in detail, but you can see it there in the diagram. Can I ask that you are up to date with the style lessons I have been setting? Also, I hope you are getting some use from these videos. I can't say that the quality will improve, but it should be a useful tool in keeping you up to date with the work we should have been doing in class. I hope you're doing well, and I will see you next time. Goodbye.